Hello, this video is on the length of an arc, as shown here in the syllabus. The formula for the circumference of a circle is given on page 2 of your formula booklet. And the formula for the length of an arc is given on page 6. You should already be familiar with the terms associated with a circle, as shown in the diagram, along with the two formulae shown below. The ratio of an arc length, L, to the circumference of a circle, 2 pi r, is equal to the ratio of the central angle, theta, to the entire angle, 360 degrees. This gives the length L of an arc is equal to theta divided by 360 multiplied by 2 pi r, where theta is the central angle and r is the radius. The arc length will be relatively short if the central angle is small, and the arc length will be relatively long if the central angle is large. In this example, an arc AB subtending an angle of 50 degrees at the centre of a circle of a radius of 4 centimetres has an arc length L equal to the value shown. When performing trigonometric calculations on your calculator, make sure that your calculator is set to degrees. To do this, from the main menu, select Run Matrix, then press Shift menu to access Setup and scroll down to the Angle option, then press F1 to choose degrees. Finally, press Execute. In this question, we're asked to find the perimeter of the figure shown. If we begin by using the arc length formula and start by finding the shorter arc length, replacing theta, the central angle, with 260 degrees, and r, the radius, with 5 centimetres, and then performing the calculation. So entering the fraction, so pressing the fraction button, entering 260 for the numerator, scrolling down, and entering 360 for the denominator, using the right cursor to come back up, and multiplying by 2, multiplying by, and then shift to access pi, and then multiplying that by 5, and pressing execute to perform the calculation. Given the value shown. To convert the answer to a decimal, you can just press the decimal display button. Next, to find the longer arc length, replace the central angle theta again with 260, but this time replace r, the radius, with 10 centimetres. Performing the calculation gives the value shown. To find the perimeter, we need to add the 2 arc lengths plus the 2 straight edges. Performing the calculation, so entering 65 over 9 pi plus 130 over 9 pi plus 5 plus 5, and pressing execute to perform the calculation gives the value shown. So the perimeter of the figure is 78.1 centimetres, correct to 3 significant figures. In this question, we're asked to find the perimeter of the shaded region shown. The perimeter is made up of 2 lengths, a straight length and a curved length, an arc length. To find the arc length, start by writing down the arc length formula and substitute in the values. Replace theta, the central angle, with 40, and r, the radius, with 8. Performing the calculation gives the values shown. To find the straight length, identify that the cosine rule can be used since the 40-degree angle is between the two known sides. Writing down the cosine rule, which is given on page 6 of your formula booklet, and substituting in the values, then performing the calculation gives the values shown. To find the perimeter, add your two previous calculations, remembering to use accurate values. On the calculator, we can use Shift Answer to access the previous value and then add on the first value, which we use 5.585. So the perimeter of the shaded region is 11.1 centimeters, correct to 3 significant figures.